All right, so humans can have huge, major impacts on the Earth's natural ecosystem. Some other species do as well. If you imagine like a beaver. Beaver has a huge impact on the ecosystem it lives in. When a beaver dams a stream or a river, that completely changes the ecosystem. It turns a stream into a pond or a lake. And one of the reasons for that is that humans can alter their environment more than basically any other species because of technology that humans have developed. Because of industrialization, we can radically change ecosystems. We can take an area completely inhospitable to humans, like the desert of the southwest United States, and build a huge city there, Las Vegas. Okay? And that's because we have technology that allows us to bring water in, air conditioning, things like that. So humans just have an ability to change our environment more than any other species. The second thing is because of, as we were just talking about, the actual number of people. Right? There are a lot of people living on the Earth. And those people require resources to live. They require food. They require water, shelter. They use energy, some more than others. And so to provide the resources for the needs and wants of all of those individuals, okay, significant damage can be done to the Earth. So the Earth's population is growing exponentially now. That's what we just looked at. Okay? And the more people we have, more energy, more resources they use. So natural ecosystems have what we call a carrying capacity. They can support a certain number of organisms. For example, if we talk about our courtyard ecosystem, we could say its carrying capacity for squirrels is 10. Given the resources available in the courtyard, it can support about 10 squirrels. Well, what if someone plays a joke, puts 25 squirrels in a cage, comes and releases them into the courtyard? Why not? What's going to happen, Brian?
Most of them are going to start dying.
Yeah, there's not going to be enough resources, not going to be enough food or water, and they're not going to survive. The ecosystem can only support a certain number of squirrels, and that's called its carrying capacity. Well, the Earth has a carrying capacity as well. The Earth can only support a certain number of people, okay, before we start running out of resources. When we do run out of resources, if it happens sort of regionally, that leads to some bad things. A lack, that can lead to famine, a lack of food. Okay? Drought can lead to a lack of water. It also can result in sort of wars and arguing over who controls those resources, who has access to them. Generally bad stuff. So I'm going to go here first, and then I'll come back to that. So this slide shows you what we were just reviewing. Okay? This goes back a little farther. Okay? This goes about 6,000 years ago. But again, you see linear, slow growth for a long, long time until sort of the modern age when we have modern medicine and so forth, and then exponential growth. Right now we're at about 7.5 billion. That's a huge number. It's sometimes hard to sort of comprehend. This video just kind of tries to put that in a way that we can relate to.
30-second ad.
This is a commercial. This is not the actual.
30 seconds you can't even skip it. No one cares about Cargill.
It's just a little old. So this was from obviously a little while ago, and that was when the population was just about to reach 7 billion. Since then, it's obviously has surpassed that. Now we're at 7.5, we're going to be 8 relatively soon. So all those individuals, all those 7.5 billion people, they need resources, okay, for their needs, for their wants. And so we call those resources natural resources, things from the earth that we depend on, that we use. And we can talk about natural resources in 2 categories, renewable resources and non-renewable resources. What is a renewable resource? What's that mean? Taylor? Yeah, renewable resources get replenished over time. They get renewed, replaced. Is the sun's energy renewable? Yes. Doesn't get used up. It's going to be there tomorrow whether you use your solar calculator or not. How about wind energy? How about corn?
No. Well, yeah.
It is. Can be replanted and regrown year after year, okay, as long as it's managed sustainably. So food is an example of renewable resources. So give me an example of a non-renewable resource then. Stephanie? Natural gas. What else goes along with that? There's 3 things we often talk about. Mom? Oil, and one more that goes with it. Alex? Yeah, we all call those all fossil fuels. Coal, oil, natural gas. Those are things that we remove from the earth. They were formed millions of years ago. We extract them, burn them, but they're gone. They're used up. They will not be returning. They will not be renewed. Minerals that we mine out of the ground, once we take them out and use them, they're not going to be replenished. So often we use these resources to generate electricity so that we can do other things. Air condition our house, charge our iPhones, have lights, and so forth. And that electricity can come from many different sources. Some of those are renewable. Has anyone ever seen wind turbines around? We have a fair amount of them around here. Travel south, like down Route 12 towards Waterville, you see there's a bunch of them down there. If you go on the thruway and you're traveling east towards Albany, you look north, you'll see some off in the distance, up north, and like Turin, there's a whole bunch of them. But yeah, these are wind turbines. They utilize energy from the wind to spin a propeller, which turns a turbine, which generates electricity. And they don't look huge. Look at this person. These are huge, huge turbines. They don't look at from the distance. If you ever go near one, they're huge. I was once on the freeway going towards Albany, and coming the other way was a tractor trailer, and it had a single blade from one of those propellers on the whole bed of the tractor trailer. It took up that whole thing, just a single blade. They're really big. But again, wind is renewable. The wind doesn't get used up. Whether you have turbines or not, it's not like you're going to use up more of the wind. It's not going to be as windy tomorrow because we put all these wind turbines up. And they generate electricity. Hydroelectric power, when you use the movement of running water to turn a turbine and generate electricity. This is the Hoover Dam. Solar energy. We can use the sun's energy in photovoltaic cells, like the one in your calculator. Okay? On a larger scale, okay, you can have large solar panels which turn sunlight into electricity. Anyone have these at home on your roof? Becoming more and more common now. Have you seen them on roofs around your house or somewhere? This is actually pretty cool. This is the newest version. These are solar roof tiles that are produced by Tesla, the car company. And these individual tiles, they look just like shingles on a typical house, but they're actually small solar panels made of glass. And they're starting to become popular, or they're starting to be released now, and, what's that? Yeah, usually if you get these Tesla solar shingles, roof tiles, they put a big battery in your house to store the electricity that's being produced, to charge up your Tesla car. Tesla's an electric vehicle. There's more and more electric vehicles or hybrid vehicles that use less fossil fuels. This is geothermal energy, using the heat from within the earth to produce heat or electricity and so forth. So these are all renewable sources of energy. These are non-renewable sources of energy. We call them fossil fuels. Okay. Coal, which is often burned in power plants to generate electricity, mined out of the earth. Oil, pumped from the ground, can be refined into gasoline, okay, fuel oil. That's what it looks like when it comes out of the ground before refining. Natural gas, which gets trapped in pockets within the earth, can be extracted. Okay. These are fossil fuels. You take that gas out of that pocket in the earth and burn it, it's gone. It's not coming back. The other issue with these fuels, besides whether or not they are renewed or not, is what? It's a major difference between solar, wind, hydropower versus these, right?
They give off like fumes and
Yes.
smoke.
Fossil fuels release significant amounts of pollution, carbon dioxide and other pollutants into the atmosphere, which can lead to a host of environmental impacts. So when we talk about preserving some of these resources, you guys have all seen this, right? Reduce, reuse, recycle, sort of a slogan. So we can reduce how much of these resources, so we all need resources, we all use them, but we can reduce the amount we use by using these three things. So reducing is just using less. Maybe it's by buying more efficient appliances. You ever seen like an Energy Star sticker on a refrigerator or something?
Yeah.
It means it's more efficient, that it's going to take less electricity to use that refrigerator versus another model. Reducing the amount that we drive, like walking somewhere, riding a bike somewhere instead of driving. Using less packaging and materials. Things like that can reduce the amount of resources. We can also just, rather than using disposable products, we can try to reuse things multiple times. For example, my coffee mug I've used hundreds of times this year alone. Again, I don't need to get a paper cup or a styrofoam cup or something and fill it up every day, and so I'm consuming far less resources by drinking out of a reusable cup. To create products that last longer, that aren't disposable, helps preserve some of those resources. Then finally, the things that are going to be disposed of can be recycled rather than thrown into a landfill. Recycling is turning waste into something actually usable. Or recycling paper. You throw your paper in this blue recycling bin. Each night the custodian brings it to a dumpster on the side of the school for recyclables. Once a week, the garbage company comes, takes it to the recycling center. That will get ground up somewhere, turned back into another paper product. You're recycling your cans and bottles, they get turned into new cans and bottles. So again, requiring less resources. All right, we're going to talk about now some specific environmental issues related to air pollution. One of these is acid rain. How many people have heard of acid rain? And when people hear it, they think, well, acid rain, like you walk outside, it's raining, it like hurts your skin and your skin's going to melt. That's not what this is. So when we talk about acids, there's a whole range of levels of acidity. Some things are very acidic and will burn your skin, like hydrochloric acid, battery acid, and so forth. But other things are not so dangerous, things like vinegar or lemon juice. Normal rain that is unpolluted has a pH of about 5.6, slightly acidic because of carbon dioxide. That's normal rain. However, when certain pollutants such as sulfur or nitrogen are released into the atmosphere, they combine with water and they form sulfuric acid, nitric acid. which mixes with the rain or snow or sleet and then falls to the earth as acid precipitation. Problem is that ecosystems cannot tolerate these acidic conditions. So as this acidic rain falls into, for example, lakes and streams, it builds up, causing them to become more acidic and harming organisms living within them. Certain trees and soils cannot buffer the impact of these acids, and the trees start to die, especially things like spruce forests and the Adirondacks or the Black Forest of Germany. Soft is a major problem too in the spring, because if an acid snow builds up throughout the winter, and then in the spring there's a sudden melt, all of that acidic water is moving into the ecosystem all at once, shocking the organisms living there and possibly killing them. Here's an example of that. This shows what some specific organisms and what type of conditions they can tolerate, acidic conditions. At a pH of 6.5, which is in a lake is pretty neutral, all of these organisms can survive. If the pH drops and it becomes more acidic to 6, they can all still survive. But then as we continue, if we drop to 5.5, the mussels are no longer able to survive. If we drop even lower, then you lose the mayflies, the smallmouth bass, they can't tolerate it. And as we move down and get more and more acidic, very few organisms can survive. There are some lakes in the Adirondacks that are dead lakes. They become so acidic, nothing lives in them. They look very clear and clean, but they're only look that clear because all the organisms within them have died. Orange are areas where acid precipitation is a larger factor. And so where is that?
East to east.
The east, us. Much of this has to do with the prevailing winds and how they move across the globe. Where does our weather come from? If you want to know if we're going to have a snowstorm in 2 days, where do you look?
Canada.
Do you look to the UK?
Canada.
No, you look to the west. Our weather moves across the country from west to east. The prevailing winds generally go from west to east. So when factories in the Midwest release pollution high in the atmosphere and huge smokestacks, it gets captured in these prevailing winds, travels east, and falls on us. So this is why if New York State passes a law requiring cleaner burning fuels, it may not actually help us very much, because much of that pollution comes from other states. That's why we have federal agencies that are supposed to help regulate pollution. You can see its impact here in a few pictures. Here you have a forest, a spruce forest that's been destroyed by acid precipitation. Certain trees cannot tolerate it, or tolerate it less than others. My last class kind of looked at me weird when I asked this. You ever like walk around in a cemetery and look like the old graves?
Yeah, all the time.
What?
So if you ever noticed like the old ones from like the 1800s, early 1900s, that are like white, and often the letters are like completely worn away, you can't really read them. It's because those were made of limestone back then. And acid rain interacts with limestone, which is a base, and erodes it very quickly. And so you see here, this statue, this is a picture taken in 1908, and the same statue in 1968. Again, limestone statue, all of its features have been worn away through acid rain. All right, last slide. This is not the great almighty smog from the Hobbit.
I remember that.
This is smog, which is a mixture. What's that called? You mix two words. It's called a pork. No, like a porkman, something like that. But anyway, smog is a mixture of, comes from the word smoke and fog. It's actually a type of pollution caused when we burn fossil fuels and then the exhaust interacts with sunlight, forming a toxic gas called ozone. Smog.
Wait, ozone's toxic?
What's that?
Did you just say ozone is
Yes.
toxic? Oh.
In the lower atmosphere. And it irritates people's lungs. It exacerbates asthma, emphysema. In areas where there's a smog problem, on the morning weather report, not only will they tell you the temperature, if it's going to rain and so forth, they'll tell you the smog index. When it's high, people are advised not to go out and exercise because they would be inhaling too much of this and damage their lungs. It's especially a problem geographically in cities which sit in a valley, like Los Angeles, where the smog sort of settles in that valley and is not moved out by winds. And this is an example. This shows Beijing, China, on a day when there was no smog due to probably the weather, the wind and so forth, versus a day when the air was very still. This is all pollution. Okay? Sometimes people wear masks to protect themselves from this. This is toxic gas that should not be inhaled. Solutions include burning cleaner fuels. There are ways of reducing the amount of this pollution released when burning fossil fuels, but it costs money to incorporate that sort of controls on cars or factories and so forth. Tomorrow we'll talk a little bit about climate change, as well as ozone depletion. Yes.
When will the owl ones be?
Oh, I don't know. I didn't even look at them yet.
Okay.
Yes.